Hey students, this is Miss Wendt, and I want to help you with page 12 of your packet, which is called Monatomic Ions. So mon means one. So these are ions that are made of one kind of atom. Okay, so now if you hit view of your assignment, and you should put it, you have it on paper, but you still should view it on Schoology because there's an info sheet. Okay, so if I scroll down, here's the info sheet that you do not have in your packet, but your packet does have the practice page. Okay, so go ahead and find your paper packet and get this practice page out. Of course, if you'd rather do it in Notability, that's fine too. But let's look at this information sheet here. Okay, so monatomic ions is the title. And it says ions are atoms that have either lost or gained electrons. So we've been looking at that in the last couple days, where atoms want to be stable and some of them will gain or lose electrons. Okay? While atoms are neutral, ions are charged particles. Okay? So we worked with atoms and we said that atoms always have the same number of positive protons and negative electrons. And those positives and negatives cancel, and they have a zero charge, which is neutral. Well, now we are moving electrons, so this won't be the case anymore. Okay, so our ions will either have a positive or negative charge. Okay, a loss of an electron, or more than one electron, results in a positive ion, and that's called a cation. And I always remember that because cat, that letter T in there, is like the plus sign for positive. So cations are positive. Now, if we gain electrons, we're going to have negative ions, and those are called anions. Okay, and that has two N's in it for negative. So cations are positive because they lost electrons. Anions are negative. Okay, now there's also a connection between metals and nonmetals. We're going to see cations are always metals. Anions are always nonmetals. Okay, so that's something to help us out too. All right, so let's scroll down a little bit here to this chart. In order to determine the charge of a monoatomic ion, you can use the periodic table as a guide. Okay, so everything in group 1, so that's the first up and down column on the periodic table, they all have one valence electron. So they're going to lose that electron, and that's going to make a positive ion, okay? Because if you take away a negative, just like in math class, if you minus a negative, you get a positive, okay? So some of the examples in group 1, sodium, lithium, and potassium, that's those symbols, and we would write it with just a little plus sign up in the corner, and it's always the upper right-hand corner. Now, everything in group 2, they're going to lose 2 electrons. So we are going to put a 2 in the column or in the upper right corner with a little plus sign. Now, if you do the plus sign first and then the 2, it's not a big deal. But the proper way to write it is the number first and then the sign. Okay, so everything in that column would be a 2. Then that group in the middle is kind of weird. Those are called transition metals, and they do weird things. And sometimes the same kind of atom can do 2 different things. We're going to come back to these in a few days if we get that far, okay? But we're not going to worry too much about those guys. We're going to kind of skip them for now. If we skip over to group 13, there's our 3. Group 14 is kind of weird. Carbon is in there and silicon. And even though they have 4 valence electrons, they don't really gain or lose electrons. They share instead. And that's a different kind of bond, okay? So we're not going to do much with group 14, okay? But, you know, if they give you something, we'll work with it. But we don't do much with group 14, okay? Then we have the nonmetals. These are going to all be negative here. So group 15 needs 3 more valence electrons to be happy. Group 16 needs 2. Group 17 needs 1. So you can see that how those symbols are written with the negative signs. And then the very last group, group 18, this is our special group called noble gases. these guys are happy the way they are. Their outside energy level is already full with 8. They're not going to want to lose any, they're not going to want to gain any. So they don't make ions. So when we write them, we do not put a positive or negative charge on them. It's just, they just stay the same. They're very boring. Okay, so that's a lot of examples of how to write these different guys that we can look back on when we do our practice. Now, when we say these out loud, like if you're talking on the phone or if you're a teacher teaching students, this is how you say things. The cations, the positives, we just say the name of the element, so what kind of atom it is, and then we put the word ion at the end, okay? So if I have a sodium atom, I would just say sodium, but now that it's lost an electron and it has that positive charge, we're going to call it a sodium ion, okay? Same thing with magnesium would be a magnesium ion. So all the metals that make positive ions do this. We just add the word ion to the end of their name. Now the nonmetals do something a little different. We're going to change their ending, okay? So the anions, we drop the ending off the element and we add this different piece, IDE, okay? And you're going to notice that you've heard a lot of these words before, okay? So like letter F is fluorine, but when it gains an extra electron, we call it fluoride with that IDE ending on the end. And you've probably heard of fluoride in your toothpaste or at the dentist office. Okay, oxygen, if we gain those 2 electrons to be happy, we change it to oxide. Nitrogen would gain 3 electrons, we call that nitride. Okay, so if it's a positive ion, if it's a metal, we leave the name alone, but just add ion on the end. If it's negative, if it's a nonmetal, we change the ending to "ide." Okay? And notice that in all of these, it doesn't matter what the number is, if we gained or lost 1 or 2 or 3, the rules are the same. We don't have to worry about trying to say the number. Okay? So let's try this. On your practice sheet, we've got a chart here where we're going to kind of look at these different symbols. Now, I got one set up with a periodic table here that we can kind of look up symbols. And you should have a periodic table kind of like this. It's probably yellow or pink. And I want to point something out to you. On your periodic table, do you see this positive or negative number that's in the corner here? And some elements have more than 1, and that's okay. Notice that number's missing in this last group. Okay, that number is called our oxidation number. That's our ion charge. So your periodic table actually already gives it to you. You don't have to think about it. But if you look, everything in group 1 has an oxidation number of 1. Everything in group 2, positive 2. Everything in this middle group down here is kind of weird, and we're going to ignore it for now. Okay, these guys are positive 3. This is a mixture of metals and nonmetals, so it's kind of got some weird things going on there. 15, negative 3, negative 2, negative 1, and then our happy noble gases, they don't make ions. So your periodic table is going to be really helpful for us to determine our answers on our sheet here. Okay, so you want to always have your periodic table next to your worksheet to look things up. So our first one is sodium. So I'm going to go to my table and look at the symbol. And sodium is right here, number 11. So the symbol is Na. And be sure to follow the capitalization rules. We want to make sure that our first letter is always capital. Our second letter is lowercase. Okay, so if I'm going to turn this into an ion, then I can look at my periodic table. It's in group 1. It's going to make a +1 charge. So I would write out the name, okay? And I'm going to type it because that's going to be nicer. Sodium ion, okay, just like our examples. I left sodium the same and I just added the word ion at the end. my formula, I write the symbol, and then in the upper corner, I have to do a little number and a positive or negative sign. Now, just like math class, if it's a number 1, you don't really have to write the number 1 part. Okay, like you don't have to write 1x, it's just x. So sodium is a +1. I don't have to write the 1, I can just do a plus sign there. Okay, so that is number 1, that is sodium. Now, our second one here is bromine. So I'm going to go back to my periodic table and find bromine. Here it is, over here, number 35. Okay, so bromine, the symbol is Br, and it's in group 17 here. So everything in this group needs one more electron, so it has a -1 charge when it makes an ion. So my symbol, Br, make sure if the first letter is always capital, second's lowercase. And my ion formula would be that Br, and this one is going to make a negative. So I'd put a negative there. All right? Now the ion name, if I go back to my rules here, it said that the anions, the negative ones, I need to drop off the ending and add IDE at the end. Okay, so instead of writing bromine, I'm going to write brome and then IDE. Now, I am not going to count you wrong if you spell something right or wrong. Some of the names, they'll roll off your tongue because you've heard of them before. But if you spell it wrong, I don't really care. As long as the ending is good and I can recognize the beginning as belonging to that, you're good. All right, next one, magnesium. Magnesium is right here, number 12. Magnesium makes a +2 ion. So magnesium has 2 extra electrons it wants to get rid of. Okay. Whoops. Pen. There we go. So magnesium is Mg, positive in lowercase. And my symbol, now because this has 2 electrons, I have to write the 2. And they're going to get rid of them, so that's going to be a plus. So 2 plus on the end there. And then my name, magnesium. And it's a positive, it's a metal, so I'm going to just write magnesium like normal and add the word ion to the end. Okay, so anything that has a positive charge, you're going to write ion. The negatives have to have the IDE ending. All right, one more real quick before my timer runs out, and then you can try some on your own. The symbol for chlorine is Cl. And on the periodic table, Cl has a -1 charge. So I would put a negative. And because it's a negative, I need to change the ending on the name. So chlor, and instead of "ine" on the end, I'm going to do "ide." Chloride, which is a term that you've probably heard of before. All right, so your job is to kind of go through the rest of these. I'll give you a hint, one little tricky one down here. Neon is in group 18. Neon's over here, it doesn't make ions. So on your sheet, you might do something like, the symbol is Ne, but you might write none for the ion name, or write nothing or 0 or put an X there, because it doesn't do that. Okay, so don't be tricked if there's some of those group 18s that are already happy. Don't be fooled by those. They don't make ions, so make sure you label them that way. All right. As always, if you've got questions, come see me, let me know, message me. When you finish, please turn it in so I can check it out, and you'll be ready to move on to the next one. Have a great day.